Hello students, welcome to Edubbey Global Solution. In our mathematics class again, we're going to be looking at another subtopic under geometry, which is quadrilaterals and polynomials. And under this class, we have our interactive content team that will serve as a guide for us. We have the different type of quadrilaterals, and we have various forms of polygons that we have actually highlighted in these interactive content. Now, first and foremost, what is a quadrilateral? Now, quadrilateral is a plane shape that it consists of what? It consists of 4 angles and 4 sides. So, for a quadrilateral to be a plane shape, what we just need to know is that it must actually have 4 angles and it must have 4 sides. So, with that, let's do these activities. A quadrilateral is a plane shape that consists what? 4 angles, okay, and what? And 4 sides. Okay, there are several types of quadrilateral. These are some of them. Look at this. This is parallelogram. If you look at this, it's going to be it has what? It has 4 angles, right? This is 1, 2, 3, 4, right? And it has how many sides? 4 sides. 1, 2, 3, and 4. The same thing with rectangle. We have rhombus, we have square, we have trapezium, and we have kite. Okay, so these are listed examples of what? Of a quadrilateral. Okay, now let's do this activity. A quadrilateral has how many sides? Here we are told that the quadrilateral have 5 sides and 4 angles equal, which is not actually right? The quadrilateral must have 4 sides and what? And 4 angles equal. Now, let's look at type of quadrilateral. The first one we are going to be looking at here is square. And look at this is the shape of the square. Now, I want to look at the property of a square. The first property here is telling us that the two pair are parallel. Okay, all sides are equal and all angles are equal. Then the diagonal insert at right angles. So the very first one here, we have 2 pairs are what? 2 pairs are what? Are equal. So we have 2 pairs are equal. That is, the length here is the same, is equal to the length here. The length that we have here is equal to the length that we have on this shape. Now, all sides are equal. If you look at that, all the sides of a square is actually equal. Then all angles are equal. So if you bisect it and we have 90 degrees, then the other one will be 90 degrees and the other one will be 90 degrees. And we can also bisect this one to give what? To give a right angle triangle. If you look at this, we draw this now. So from this aspect now to this aspect, you see this is a what? This is a right angle triangle. And if you bisect on the other hand, this to this side, this is also a right angle. And this is some of the properties of what? Of a square, okay? And let's check we are right. Now let's look at the next one, which is what? A rectangle. Properties of a rectangle. 2 sides of parallel sides. So 2 pair of a parallel side. So that implies that a rectangle actually have a parallel side. What are parallel? Lines that cannot meet, even if it is being drawn to what? To in infinity. Okay. Now, opposite sides are what? Opposite sides are also equal. So we have their opposite sides here, and this side they are equal. This is the parallel line, and this is another parallel line here. So, and all angles are also equal here. So if we divide through by setting and having the right angle, all the angles are going to be what? All the angles are going to be equal. Okay. Now let's look at the next type of quadratic that we have, which is what? Rhombus. Now, on the rhombus, we have some properties here. 2 pairs of what? We have 2 pairs of parallel sides. Okay. All sides are also equal, and 2 opposite angles are equal. Then they can now intersect each other at right angle triangle. So for the first one here, 2 pairs of parallel sides. So that implies that 2 lines here are actually parallel to each other. Then all sides are what? All sides are equal. So if you have 60 in the fourth side, you're going to be having 60 in the other side. We are going to be having 60 in the third side. We're going to be having 60 in the fourth side as well. Now, opposite angles are also equal. So if you have 90 degrees in an angle, the opposite angle also is going to give us what? going to give us 90 degree, and these are the shapes of rhombus. Look at this one. This side is equal to this side, and the other side is equal to this side as well. The same thing applies to this and this. Okay, now we are looking at what a parallelogram. From the word parallelogram, then you know that we have a parallel line in this type of quadrilateral. Okay, remember that we said that quadrilateral have 4 sides and 4 angles what equal. So now let's look at the properties of our parallelogram that we have here. 2 pair of what? 2 pair of a parallel sides. So from the word itself, parallelogram, they'll be able to know that this actually has to be a parallel line. So this side and this angle AD here is parallel to angle BC here, and angle AB is parallel to angle CD or angle DC. Okay, then opposite side are also equal. Opposite side are equal. If you have 10 in angle BC, you have 10 in angle AD. If you have 5 in angle AB rather, you're going to be having 5 as well in angle CD. Then opposite angles are also equal. That is, if you have 60 degree here, then you have 60 degree on the other opposite angle as well. Okay, now let's look at trapezium. Now, under trapezium, we're going to be looking at properties of trapezium. Now, the first one here is telling us that we have a parallel side. So, 1 pair of parallel side. Then another property here is basically the very major trapezium that we make use of is what? Isosceles trapezium. And it has 1 pair of parallel sides, and the other pair of sides are equal in length. So an isosceles trapezium has an equal size of the length, and they have a parallel side. Now, if you look at this, A in the angle below is actually parallel to what? To H. And for us to calculate a parallelogram, the area to calculate a trapezium is half into bracket A plus B multiplied by height, where there are A and B here are actually the length that we are to put into consideration if you are to calculate area of a trapezium. Now, the next one we are going to be looking at here is what? Is kite. Now, property of a kite, 1 pair of what? 1 pair of angles are equal. Then we have diagonal insert at right angle. So, 1 pair of a kite actually they have equal angle, and we can actually bisect at the right angle. Okay, so let's check. Now, this is an example of a kite. If you look at it, let's assume this is angle AG. Angle AD here is actually equal to angle AB here. Now, let's assume we are referring to this as angles BC and angle DC. So, angle DC here is actually equal to angle BC, and they are actually as well parallel to each other. And we can bisect this. If you look at this from here to this side, angle AOB is what? The right angle triangle. Angle AOG is another right angle triangle. Angle DOC or COD is the right angle triangle, and angle BOC is actually the right angle triangle. Okay, now after which we're looking at what? A polygon. We want to consider that the fact that the quadratic have 4 sides and 4 angles equal. Now we look at different type of quadratic quadrilateral rather, and we have made mention of something like some of those angles, which is what? Which is a kite, rhombus, parallelogram, trapezium, rectangle, and square. Now, once we look at polygon, any 2-dimensional closed figure that is made up of a straight line is called a polygon. Now, if you have a dimensional shape, we have it drawn in a straight line, then we can call that type of structure what? A polygon. So, if the sides are the same length and the interior angle are equal, then we refer to that figure as what? As a regular polygon. Now, there are 2 polygons are said to be similar if their angles are what? If they have the same angle and their corresponding sides are proportional. So, if we have 2 angles of a polygon to be the same, and we have corresponding sides that are proportional in nature, then we call that type of polygon a similar polygon. So now let's look at the activity we have here. And any 2-dimensional closed figure made up of what? That is made up of a straight line. So for a polygon to be a polygon, it must actually be made up of what? of a straight line. So when we have the same length and the same interior angles, then we call that type of polygon a what? A regular polygon. Now, for two polygons to be similar, the very first condition that must be satisfied is that their angles are the same. So you want their angles are the same. Now, look at this. These are actually an example of how a polygons look like. Okay, so we are going to be looking at different polygons that we have here. And what makes a polygon is we try to identify them based on their size. So we name them based on the numbers of sides that we have. And let's check. Okay, now look at this. These are the common type of polygons that we want to look at. And I've told us that we identify polygons based on the numbers of what? Of sides. So when you have three sides, we call that what? A triangle. When you have four sides, like the quadrilateral we just made mention not quite long, we call that what? Fourth sides, because it is a quadrilateral. Now, for a pentagon must have how many sides? A pentagon must have 5 sides. Okay, hexagon must have how many sides? Hexagon must have 6 sides. From the word hexagon, then you know that we have 6 sides. Then hexagon we have 7 sides, while octagon we have 8 sides. Nonagon, from the word nona, that is 9, right? So it will have 9 sides. Then decagon we have how many sides? Decagon we have 10 sides. Okay, we have talked about triangles. That triangles have how many sides? That is 3 sides. Okay, so these are just common polygons that we have here. We still have more than this. We have on decagon, the decagon, that is when you are measuring from 11 upward. Now we have a past question here. Let's see the past question and let's solve the solution for this past question. We have this illustration here. Look at this. It's actually plotted on the graph. So we are to what? We are to write down mathematical name for what? For this quadratic B. So if you look at this quadratic, what type of quadrilateral rather? What type of quadrilateral is this? This type of quadrilateral is what? Is a trapezium. It looks like a trapezium. So this type of quadrilateral is actually a trapezium. So I think I've made mentions of the formula for calculating trapezium earlier. Now we are supposed to count what? To calculate the area of the trapezium, which is what? Half into bracket A plus B multiplied by height, where your A and B are the length. Now from this illustration here, what we need to do here is, you see that we don't have any specific number for height, so we have to be counting the number of boxes. If you look, we have 1, 2, 3, 4. So if you look at this is going to be the height. We have 1, 2, 3, and 4. So the height is going to be like, let's assume that we are rating in centimeter. So the height is going to be what? 4 centimeter. The length here, which is B, is already rated in 10 centimeters. So we have that stated already. And let's count the boxes of the length that we have here as well, which is 1, 2, and 3, and 4. So the length here is where is 4. So we can now use that to solve our problem, and we have it to be what? We said the formula for calculating a trapezium is half into bracket A plus B multiplied by height, where your 8 and B are what? Are length. So we have 1 multiplied by, we said we have 10 centimeter, right? Then plus 4 centimeter, those are the length. Then multiplied by height as well, which is 4 centimeter. Remember, we are calculating what? Area. So we are denoting that with A. So we have it to be half into, that is 10 centimeter plus 4 centimeter will give 14 centimeter. Remember, we say we are still multiplying by what? Multiplying by 4 centimeter. So if you bring that here, 4 can actually cancel 2 and it will give us 2, right? So we have 14 centimeter multiplied by 2 centimeter left. 14 centimeter multiplied by 2 centimeter will give us what? That is 28 centimeter square. We are calculating area. Now, this takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thanks for listening.